Hey everyone. Okay, so this is our last lesson of our polynomial functions unit. And here we're going to deal with applications. So applications are just a fancy way of saying word problems. A lot of the application type stuff with polynomials, we go through on a graphing calculator. So what we want to do with this lesson, I'm going to pose a scenario, and then I'm going to ask you a bunch of different questions on that scenario. And we're going to go through how to figure it out from your graphing calculator, what specific buttons you're going to need to press, and that sort of stuff. Okay, so as we have seen, a great number of questions can be asked for any particular equation or function. We have also seen that particular types of questions correspond to particular characteristics of a function. Now I'm just going to hide my head here for one quick second in case you can't see that full paragraph. Okay, and now here is our sample scenario. So a rock is thrown off a bridge into a river below. The path of the rock can be modeled by the equation h of t equals negative t squared plus 2t plus 8, where t is the time in seconds, and h, the height in meters above the river. And we're going to round our answers to the nearest tenth when necessary. Okay, so I've got that sample scenario up at the top there for us. First question, what is the height of the bridge from which the rock is thrown? Now, the characteristic that we're looking for there is the y-intercept. How to find it? Well, actually, I would want you to know that the y-intercept is the same as our constant term, right? We talked about that when we talked about the characteristics of polynomial functions. So our constant term, we can see right up at the top of our scenario here, the equation, our constant term is 8. So it would be 8 meters, okay? Now, either you get it from the constant term, or you can remember that the value for x would have to be 0 there if we're looking for y-intercept, right? So you can plug 0 in this case it's t, not x, but our input is 0. So we could plug 0 in for t and solve it that way. Or on a graphing calculator, you could go trace 0, enter, and get it that way, okay? No matter how you look at it, you are looking at an answer of 8 meters. Now, when you do give me answers here, make sure your answers include the specific unit, right? This graph would be, the t value would be in seconds, and the h of t value would be in meters. So we need to make sure you know which unit you're talking about at which time, okay? Okay, how about the maximum height of the rock? For that guy, you're going to calculate the maximum point on your calculator, specifically the y value at the maximum point, right? The x value would tell you the time it took to reach the maximum, but then the maximum itself would be the y value. Now, to get that, you would go find the maximum. So on a Casio, you would go G-solve maximum, okay, and it would take you right there. On a TI, just a little trickier on a TI, you would want to go second trace and then choose the maximum option. But then it's going to ask you a series of questions. So the first thing it says is left bound. So if you're looking at your graph, say this is your graph here, okay? You're looking for that point right here. So anything over here is left bound, okay? And then anything over here would be right bound. So you just have to put your cursor so that you're left of the hump, hit enter, then it will ask you to go right bound. You put your cursor so that you're right of the hump, hit enter, and then it'll ask you one more time if you want to guess, and you just hit enter through that, and then it will give you the correct answer after that. Okay, so in this particular example, it should be 9 meters. Okay, so you should get a y value there of 9 meters. Okay, didn't ask you how long it took, so we don't need to state the x value anywhere, but that could be another question as well, is how long does it take to reach the maximum? And then that's when you would say your x value there. Okay, but for the maximum itself, it is the y value. Okay, good. The time at which the rock hits the water. Okay, now For that, you're looking for the 0, okay? So if I think about what this picture looks like really quick, it's gonna look something like that, right? And so right there is where I'm hitting the water. Okay, so on a Casio, that would be G solve and then root. Okay, now, depending on what your window is, let me just extend this for a sec. Remember, there is a root over here. So your Casio, if it can see this one, it's going to take you to the one on the left first. You just click the right button and it will jump over to here. Okay. There's a couple different ways you could do this on a TI. I think the easiest way is the way I've written, which is in Y2, stick a 0. It doesn't look like it changes your picture at all, but essentially what it does is it creates another line that's directly on top of the x-axis. Then you can solve the intersection point of this guy with this guy, which is second trace 5, enter, enter, enter. Okay. There's also a 0 function on a TI. So if you like that better, you could do that. You'd go second trace and then choose the option that says 0. Again, though, it asks you for left bound and right bound. So if you're going to do that on a TI, remember that you're always reading graphs this way, right? So left bound would be this side and right bound would be this side for that particular x-intercept or root, okay? Here, just as a clarification, if you were looking for this guy, you're not, friends. I want to have a conversation for my TI friends right now. If you were looking for this guy and you're choosing to use the 0 calculation, just notice that this would be left bound and this would be right bound up there. Okay. All right, let me get rid of that and we'll just add in our answers here. So the characteristic is it's the x-intercept on the right, okay? And our answer is 4 seconds. Now, this one, you actually could have solved in this one algebraically for that, right? You could have put h of t as 0 and you could have gone and factored it. This would have been a factorable polynomial, so you could have gotten your answer that way as well, okay? All right, the time at which the rock is 7 meters above the river. Now, what I want you to see there is you are given a y value and you're being asked for the x value. You're being asked for the timestamp when the y value is 7. Okay, so really, this is similar to the last question in the sense that in the last question I just gave you, you're essentially asked for the timestamp when the y value is 0, right? Now it's the timestamp when the y value is 7. Casio kids, you have, oh, let me just actually say what we're doing there. It's the x value when the y is 7, okay? Casio kids, you have a function inside your gsolve that says xcalc. So you can go gsolve and then you just got to go to more options and then you'll see xcalc there. And then it'll just say, hey, what's your y value? You just say my y value 7, hit execute, and you're done. TI kids, I would approach this probably the same way as I told you to approach the 0 in the last question. Go to your Y2 and just instead of having 0 there, put 7 there and then solve the intersection. Just remember that when you're solving an intersection like that, it's the x value of the intersection. It's not the coordinate point there. This is not a systems of equations, okay? Okay, when you do that, you should get an answer of 2.4 seconds. So hopefully you're trying this along with me as I'm explaining what to do on a calculator for all these things. Okay, what are the restrictions on the domain? Now, what I need you to understand about this sort of a conversation, again, I've already alluded to this, but your picture looks something like this, right? Where this is where I threw the rock and this is where the rock ends. From a purely mathematical perspective, this is a quadratic, the domain would be real, okay? But what we need to think about is we need to think about what's meaningful in the context of the question. I actually don't care about anything over here because it's all negative time, okay? I can't go backwards in time. I don't care about anything after here because by that time the rock has hit the water. So the conversation is kind of over. Okay. So my meaningful domain is actually only from here to here. That's the only part of this graph that has meaning in the context of the question. Okay, so I already know what those things are. I know that this point here is 0 and this point here is 4, so my domain ends up being from 0 to 4. Okay, so we'll just take that out, and this was just the little conversation I just had. The domain, as far as the math is concerned, is that x can be anything, but not everything has meaning in the context of the question. And so we end up with 0 to 4. So all the values of x such that 0 is less than or equal to x is less than or equal to 4, and x is a member of the reals. Awesome. What are the restrictions on the range? Same sort of conversation. I don't care about the rock burrowing down into the water. Do you burrow in the water? I guess you sink in the water. And then I can only go as high as 9. So my range is actually going to be from 0 to 9. Okay. So all the values of y such that 0 is less than or equal to y is less than or equal to 9. Do you know what? While I'm having this conversation, I'm gonna correct myself here. Really, this would be better in the context of the question. In the context of the question, it's x is not x, so we're gonna fix that. X is actually t here. So let's write that as a t, not as an x. Okay, so the domain should be 0 is less than or equal to t is less than or equal to 4. That's way better. And then likewise, when I go back to the slide I just was at, we're going to fix that guy as well, friends. And we're going to call that h. You call h, you call h a t, whatever you like. But that's better because it's you interacting with the context of the question. Okay, so I'm going to say all the values of h of t such that 0 is less than or equal to h of t is less than or equal to 9. And h of t is a member of the reals. That is a way better way to answer that. Okay, so because now you're telling your teacher you're thinking in the context of the question, and that's going to make your teacher super, super happy. Okay, all right, cool. How long is the rock above 8.5 meters? Again, the 8.5 is a y value, okay? But what I want you to think about here visually, if you're looking at the picture on your graph, you've got something like this, okay? And essentially, let's just take a look at, say, this point here is where I begin to be above 8.5, and this point here is where I end being above 8.5. So the subtraction of those two items ends up being the time that I'm above 8.5. Okay, so you need to find two different x values here, the lower one and the higher one, and then you're going to need to subtract them. Okay, so find the x value where it first begins to be above 8.5 meters, then find the x value where it stops being above 8.5 meters, and then the distance between the two of them will be your total time. Of course, I'm assuming as we go through this whole video, you keep pausing me and trying these yourself, because that's how you're going to feel really, really good about this stuff. Your two timestamps are 1.7071 was the larger number, so that was the one on the right. And then 0.2929 was the smaller number, that was the one on the left. And then I subtract those two things and get 1.4 seconds. Okay, so again, how am I finding those? Well, if I'm a Casio kid, I'm going to go gsolve xcalc and type in 8.5. If I'm a TI kid, I'm going to go y2 is 8.5 and solve the two intersections and look at those x values that way. Hey, if I'm a Casio kid, I can do it that way as well. If you like that better, that's totally fine. You can go to y2, put in 8.5, and just solve for the two intersection points. Okay. All right, so if we put all these things together, we were looking at this graph. This was the graph that got generated. And I'm just going to quickly run through everything we just solved one more time. So the height from which the rock was thrown, that was the y-intercept. We could get that as the constant term, or in our calculator, we could go trace 0, execute, or in our brain, we could plug in 0 for t. Okay. The next question I had asked you was the maximum. So the maximum height of the rock and we could also get the time it took to get there. And we're going to do that on a Casio by going G solve max. On a TI, we're going to go second trace max, do my left bound, right bound, and work through my guess. Okay. Then I asked you the time at which the rock hits the water. Do you know what? Just I'm going to hide my head for 1 sec just in case you couldn't see the maximum height of the rock. Okay. When I record these things, I move my head all over on the screen so I can see stuff. And sometimes I forget where it's going to be located in the recording. Okay, so the time at which the rock hits the water, that was the x-intercept on the right. And if I'm a Casio, I'm going to go G solve root. If I'm a TI, I could go y2 equals 0 and solve the intersection point. Or I could go second trace 0 and go left bound, right bound. Okay. Then I asked you the time at which the rock is 7 meters above the ground. That is a y value. On a Casio, I'm going to go G solve x calc 7. And then on a TI or on a Casio, I could go y2 equals 7 and solve the intersection point. Okay. Then we talked about what my meaningful domain was. So it was only when time was positive and until the rock hit the ground. Meaningful range would be, again, positive and up to the maximum height. So that would be my meaningful range, assuming that's going down all the way to the x-axis, right? And then the last one I asked you was the length of time the rock was above 8.5. So then again, just a visual, I start being above 8.5 right there, and I stop being above 8.5 right there, and then I just subtracted the two of them. Okay. So those are kind of all the different types of questions we can ask and how you would approach them, mostly from a graphic standpoint, graphing calculator standpoint, but some of them from an algebra standpoint as well. Okay, so here is some stuff that you get to practice now. Yeah, make sure you do so. Make sure you're checking your answers and asking me if you have any questions. I hope this was helpful, guys. Again, make sure as you're watching these videos, take the time to pause, try it yourself, go back, re-listen. That's the advantage of having a video, is that you can revisit certain questions or certain things that maybe you didn't catch the first time, okay? I'm so glad to journey with you along our path here in polynomials. Congratulations on finishing polynomials now. And thanks for watching. Thanks for coming along with me to go through this. And thanks for sharing these videos with your friends. I really appreciate that. And as always, thank you for subscribing to my YouTube channel. It means a lot. You guys are rocking this, and I hope you're doing okay. I hope you're feeling good. We will see each other for a new unit pretty soon. Take care, guys.